Hello, today we're working on systems of linear equation notes. All right, so a system of linear equations is a set of two or more linear equations that are given together, such as the example at the right. So just like this is two linear equations that are given to you together, and they are a system of linear equations. To represent a system of linear equations graphically, you can simply graph each line on the same set of axes. The lines may or may not have a point of intersection. In this case, they do. This is their point of intersection where they intersect with each other, and this point is 1, 2. All right, also notice that the point of intersection lies on both graphs. So notice that it is a point on this line, but it's also a point on this line. Okay, what that means is that it is solution to both equations in the system. It's the only solution to both equations on these axes. So in this particular problem, this is the only point that these two lines have in common. All right. So this point is true for both equations. It's the only place that's true for both equations. Remember, every point on a line is a solution to that equation. In this case, this one point is the only solution to both equations. Okay, solution to both equations. And so we can prove this. We can show that this point 1, 2, is true for both equations. So what we're going to do is we're going to plug in that 0.12 into both equations. So I'm going to put the equations up here. All right, and into both of those, I'm going to plug in this point, which I'm going to do with some colors. So my y value is 2 equals 2 times 1. So I plugged in my x and y into this equation. And now I just have to prove that these two sides are equal for this point to be a true solution of this equation. So all I have to do is 2 times 1 is 2. 2 equals 2. Yes, it does. That's true. So then I'm going to do it with the other equation, plugging in 2 for y. Plugging in 1 for x. Again, I just have to solve this side. -3 times 1 is -3. -3 plus 5 is 2. Again, 2 equals 2. That is true. So it's true for both equations. It's the only solution that is true for both equations. All right. So this isn't the only possibility. There are 3 possible relationships between two lines on a graph. So we've already done one of them. One possible relationship is that they intersect. So one possible relationship is that they intersect. Oops. Which means they have one solution to the system. Each line has infinitely many solutions, but to the system, there's only one solution, and that one solution is right there, where they intersect. All right, there's 2 other possibilities. One of those possibilities is that the lines are parallel. If the lines are parallel, I'm going to try to make these as parallel as possible. If the lines are parallel, the definition of parallel lines is that they will never, ever, ever intersect, ever. which means there are no solutions to the system. Again, this is all in reference to the system. So there are no solutions to this system because they never intersect. No intersection means they have no common solutions. So because they have no common solutions, there are no solutions to that system. So that's possible. There's only one more possibility. And it's going to look really weird on this graph when I do it. But try to follow along with me here. So I am going to make two lines. So here's one line. But I'm going to put another line right here. Now I have them overlapping in this strange way because I really want to show that there are two lines here, but you'll notice they're right on top of each other. So what we say is that they're the same line, meaning they overlap everywhere. If they are the same line, if they overlap everywhere, that means they intersect everywhere, right? So unlike our first example where there's only one solution, they only intersect one place, these two lines intersect in every place. And what we call that is infinitely many solutions. So if they're the exact same line, they'll have the exact same solution over and over and over and over again. So there are three possibilities. You can have one solution,